Thank you so much, everyone, for joining us. I'm very excited to be here with Rebecca and Carlos to share a bit more about this collaboration, our organizations coming together to see what could happen if we leverage our respective strengths in aerospace and cloud computing, machine learning, and to see what this could do for improving forest monitoring systems. And truly, this was an applied project, putting this all together in practice in Brazil. So I'm just going to set some context, and then I will hand it over to Carlos and Rebecca to share a bit more. At Planet, we have a mantra that I think you kind of just heard from Andrew, and it's that you can't manage what you can't measure. And traditionally, using remote sensing or satellite technologies to monitor forests, it's required some trade-offs between the spatial and temporal resolutions of satellite imagery itself, but also computing capacity for analysis. And as we just heard from Andrew, the spatial and temporal resolutions of satellite imagery with data sets like Planet, for example, these are drastically improving even just in the past few years. But at the same time, I think what's really been interesting is our ability to understand what all that information is telling us is also really advancing. So we have platforms like Google Earth Engine where you can process massive amounts of satellite imagery, and you can even have machine learning-based tools like TensorFlow right there in the interface for the users. So this project, we really kind of came together and said, what if we took these technological advances, what if we combined them with the science and policy expertise within Brazil, within Biomas and Imazon? What would it look like if we tried to create some new systems in practice? And so with that, I'm going to hand it over to my colleagues, Rebecca and Carlos. First, over to Rebecca, who, as we heard, is the director of Geo for Good and Google Earth Engine, to share a bit more about kind of the technological advances that are enabling these approaches. So, Rebecca.
Thanks, Tara. Hey, everyone. At the risk of embarrassing my friend Carlos, I would like to open with a story and put sort of a little bit of a human face on this project, because sometimes, you hear about Google's doing something and it seems like this big sort of anonymous thing. But actually, the technology that I'm going to talk about, Google Earth Engine, might very well not exist except for Carlos. And it was born in the Brazilian Amazon in 2008. I was down there representing Google Earth. We were working with indigenous communities to help them use Google Earth as a tool to defend their territory. And someone introduced Carlos and I, and he said, Rebecca, I'd really like to talk to you about a different idea. We love Google Maps and we love Google Earth, but you just let us look at the imagery. And we have a real problem in the Amazon. We're losing 1 million acres a year to deforestation. Much of it's happening in remote places where there's not good law enforcement on the ground. However, satellite imagery exists that's collected every day and we have the science to do change detection on that, such that we could build a virtual alerting system. And we have, but the problem is it's terabytes or petabytes of data. It takes us weeks just to download it and process it, and by the time we have the result, it's almost irrelevant. And he said, you apparently have a lot of computers at Google, and you have, the imagery, but instead of just letting us look at it, how about letting us do science, change detection, map and measure and monitor the changing surface of the planet? And I thought, that's a pretty compelling presentation, but who is this guy anyway? So I started asking around, and I was like, who is this Carlos Souza? And people were like, he's just one of the world-leading remote sensing scientists. You should listen to him. So I brought the idea back to Google, and we started a prototype that ended up taking off, and Carlos built the very first Earth Engine-powered application, which has now developed and grown and to the project we're going to talk about today. So I just had to share that. You can blame him for Earth Engine. So getting back to that challenge he posed, there's so much data. So the Planet data you've heard about is an incredible advance in terms of temporal and spatial resolution. It comes on together with a whole host of public data that's been collected for decades by the US government, European Space Agency, and so on. Extremely valuable information. The problem is these images collected over decades, sometimes back to the 1970s, they come in, and typically they're stored on tapes in government vaults. And so the data is extremely secure, which is good, but it's a little bit inaccessible. And if you historically wanted to access that data and do analysis on it, you had to email a request or go to a website, and it would take weeks for them to get the data off the tapes and then put it online, and you would get maybe a few images. You can imagine that that really limited the type of science that people like Dr. Carlos Souza were able to do. So we worked with the US Geological Survey in a partnership. We built the Earth Engine platform to basically be able to liberate all of that data, petabytes of data stored on tapes in government vaults, into the Google Cloud, co-located with massive amounts of computation for processing, and an easy interface for scientists to be able to bring their methodologies into the cloud and run it at scale. So basically, they didn't have to worry about all of the complexity of managing the data and having the data update every day and having enough compute. They could just focus on the science. So that is Google Earth Engine. If you go to earthengine.google.com, you will see you can learn all about it. And again, thank you, Carlos, for giving us the idea. And we put it, freely into the hands of the world's scientists, the nonprofits, and so on, and it's being used in incredible ways. But one of the first things we did as Google with the platform, once we had brought the decades of imagery from the Landsat catalog online over the entire planet, we said, well, what if we could build a time-lapse animation? And this, I'm going to go back. Yes, I can go back and come into it again. Yeah, so we're looking here at Las Vegas growing while Lake Mead shrinks over a 3-decade period. Las Vegas was the fastest growing urban area in the country. We have this type of 3-decadal imagery for everywhere in the world. If you go to earthengine.google.com/timelapse, you can go anywhere, and it's fascinating to see the kinds of changes. The reason I mention it is because to put that together, it looks simple, but we ended up analyzing 15 million images over 35 years from the Landsat and Sentinel satellites. It was 10 quadrillion pixels, because you have to sift through those pixels over the course of imagery over a year and find ones without clouds and shadows and so on and stitch it together into this kind of seamless global animated time-lapse. It was 4 million hours of computation to do that, but because we ran it on 66,000 computers in parallel, we had the result in a couple days, whereas on a single computer, it would have taken more than 300 years. So that's, yeah. Yeah. So we realized that this platform was less about letting someone do in an hour what could have taken, or in a minute, what could have taken an hour. It was going to be more about letting people ask questions that were never possible to ask and answer before because of the scale. And that gets to the science. One of the first large-scale global analyses that was done using Earth Engine was by Professor Matt Hansen, University of Maryland. It was the first high-resolution picture of forest cover and change over 12 years. And this was 1 million hours of computation. It would have taken 15 years to complete, but we had it in 4 days. So this is the picture that I wanted to convey. We're not the scientists. We're trying to turbocharge the best science in the world. And now kind of moving forward, so the platform has an hourly updating catalog of hundreds of data sets. We're now up to 30 petabytes of data, and it's weather and imagery and so on. And then people can bring in their own data. For example, when they source planet data, they can bring that in and fuse that with the other data sets. And it has all of the traditional types of geospatial processing algorithms, but we also have now integrated, as Tara mentioned, AI. And so AI is good when you don't have a really good scientific model, the kinds that Carlos Souza has historically created, but where you have a lot of training data and you can try to learn about phenomena on the planet. So we've now got a very tight integration between Earth Engine and AI platform, so people can do all kinds of machine learning and algorithms. One just example, because I know we're focused on forests, but just to kind of stretch your thinking a little bit, where I think this is very exciting is there's sort of 2 dimensions. One is the scale of what people can now do, global analyses of high-resolution data and have results very quickly. But the other is the near real-time aspect. Because one of the other challenges we found for epidemiologists who are trying to eliminate malaria is you can predict where mosquitoes are going to hatch weeks in advance using satellite data, weather information, rainfall, temperature, the greening of a landscape that you can see in the imagery, and then knowing where there are villages that have not had bed nets or spraying done, and you can create kind of a spatial analysis of risk. So the science to do that has existed for decades, but the problem is the practitioners in Africa, they don't have the wherewithal to manage all of that data coming in every hour to make those daily updating predictions. This is, again, where these kind of cloud computing platforms can can give you near real-time information. So the map on the left is what was the best map of malaria risk in Swaziland, and it basically showed half the country was at risk. It doesn't give you actionable information to decide where to send people to do bed nets or spraying. The map on the right is the near real-time Earth Engine analysis, which shows you those precise red hotspots of where you need to prioritize your resources. So it's called precision epidemiology. And so just to sort of end before I turn over to Carlos, I think this is really exciting when you look at things like the Sustainable Development Goals, where the countries, and I think Andrew mentioned this as well, where the countries are trying to have the data to make actionable decisions, to make progress on incredible global challenges, and they do not have good data. I think only 20% of the SDGs have good data, and even if they have data, it's often old. And the potential of Planet and cloud computing and AI and the best science to turn all of that raw, massive data into extremely precise, actionable information for decision makers of the world, we're really at the dawn of that age. So with that, I would like to turn it over to Carlos.
Yeah, it's hard to follow her. I'd say. I had all set up for my presentation, but let me tell you something. Going from idea to build something disruptive, such as Earth Engine, requires leadership. Without her, I think we wouldn't be talking about
I paid him to say that.
But it was really, I saw in the first years the way Rebecca took seriously this mission. She made several partnerships with space agents, governments, talking to many, many people global-wide. And now we have this fantastic technology. So we're talking about disruptive technology. We also have planet constellation, satellite constellation. And the idea behind NextGenMap is what could happen if we put together these two disruptive technologies. I'm a scientist, I'm a remote sense scientist, but I'm always looking at the application of this type of technology to solve big problems, which is stop deforestation in the Brazilian Amazon. I will start showing initially how we used to work and how we think about going with the NextGen project, okay? So these images are coarse resolution images, 30-meter pixel size. On my left, on your left, you have in black all deforestation. The green are forests that we mask. We don't want to look at the areas that had been deforested before. The second image in the middle is an image, a Landsat image 1 month after that. And then you can see the fire plumes, the smokes coming out. The purple colors are fires. You probably heard about the big fires in the Amazon region that came up in August, September. And in red is the new deforestation. Most of these fires are in pasture lands, but a lot of the fires were also to clear up new forests. So we process these quickly using Earth Engine. But in terms of application, what it's a norm, what is usually done, we send this information out to environmental agencies, especially municipalities in the Brazilian Amazon that don't have access to the information. And by the way, our system is an independent forest monitoring system. The government has also its own system in Brazil. We our vision that we can foster transparency in the government side with our system. We also don't have to wait for the government data to be released. In this example, people go there, collect evidence that there was an illegal deforestation. This is required by law. If you really want to use this information to enforce the law, it is necessary to do this kind of field verification. But you can imagine doing that across the Brazilian Amazon. There are a lot of inaccessible areas. Over the past 10 years, we have had information for 5,000 sites that had been visited, so we are not covering the entire amount of deforestation alerts because it's not practical. So with the new system that we're building in the NextGenMap, our vision was to build like a traffic radar system where if you cross a red line, your car plate get the photo, you receive the fines in your home, right? By mail. So the level of detail that the planet data can provide is very easy for a judge or a person in charge of law enforcement to recognize that there was a deforestation. Once we have the alerts detected from the coarse resolution images, we search the planet data sets, and then we find the area before deforestation. So I have forest in this image, and then we see a change. The next step, just going back and forth to give you a better idea of what's going on. Once we confirm that there is deforestation, we prepare technical documents. The platform is called Map Biomas Alert. On the left, you have the Prodigies, the TESS, SAD, GLAD system, all alert systems that are in place. Those are the information that allows us to search for the planet data and zoom in those areas and prepare the technical reports. We also combine these polygons and satellite images with land registry, database, and also permits. Some areas are legally deforested, so we have to combine all this information. And once we do that, we send this information to the public prosecutors. So we really want to create a shortcut. We don't need to go out in the field. The idea is to change behavior. So when we want to think about impact, what we do from the technological side is to change the conditions. So we have better information, better tools to implement the laws. But we need to work on the change behavior side if we really want to have an impact. So the Amazonia Protege, it's a portal where we have right now almost 10,000 polygons that had been evaluated using planet data in the hands of the public prosecutors. And most of these cases are already in the court level. They had been sent to judges. It is hard for the judge to make a decision, just look at the coarse resolution satellite images. Our vision is that they will recognize this as a digital photo. They don't need to be a remote sensing analyst. And this can actually make a big difference, because if we don't work on the law enforcement side, we will be just monitoring the Earth. Mm-hmm. As you said once to me, we'll be filming the obituary of the Earth. That's not what we want. Yeah.
Capturing the obituary of the planet in higher and higher resolution. Not the goal.
Yeah, not the goal, exactly. Where we are now, we have this platform. It's open source. You can access the code that we built to develop this platform, all the data, all the analysis, all the reports, and there are a lot of applications that are emerging. I just mentioned the law enforcement. We had a meeting 2 weeks ago with the state environmental agencies in the Amazon region, training their technicians to use this information. It's ready to use this type of information. Supply chain traceability is another information. We also work with the financing sector. They don't want to invest in creating new deforestation. And very interesting that other NGOs that are doing more in-depth work, such as Global Witness. They want to use this to connect this information with the supply chain to see if big corporations are actually buying from illegally deforested areas. My final information to share, now we have this for the entire country. We used to have only for the Amazon region. It's covering Brazil. We expanded this to Indonesia. That's the next level. Eventually, we will be reaching out to the Pan-Amazonia countries as well. For the analysis that we have in Brazil, 90% of the clearings are illegal. And I'll end with that.
Wow.
Thank you.
Staggering. Thank you both for sharing. I think the most important message that I've heard in that, Carlos said, really, we have to target this at changing behavior. And as Rebecca said, this isn't about watching, the obituary of the Earth in higher resolution. And I think, for me, one thing that struck me as so successful in this project is pairing these technological advances with the local knowledge. And I think when we think about applications, that's a collaboration that we should really seek, and it has to be across sectors. So now we're going to go to some Q&A. I have a couple of questions, and then would love to open it up to the room. First, we heard Rebecca talk a little bit about the scalability of the technology, and these technological capabilities are now at global scales. But again, thinking about that local knowledge and the ability to adopt it into practice, Carlos, how scalable are these approaches, and what is the pathway to adoption that you see?
I would say that it will depend on the end user. In this meeting, I just mentioned this workshop that we had 2 weeks ago. We started, Tasso and I started saying that we really would like to see impact.
Yeah.
So because we don't want to keep running this without the impact. I think we have to bring the private sector as well to the table to show that this is totally feasible to implement. I have talked to many companies. They think it's too complicated to implement, so we want to take care of these parts. And then I think that from the impact perspective, we're putting a lot of efforts to train the judges that will use this information to enforce the law. So I don't think it's a technological issue. There is a cost involved, but it's much cheaper to do that than going out in the field to enforce the law. So it's a matter of having practical applications in measuring the impact of this.
Yeah. Yeah, and so speaking of private sector engagement, I think this conference actually has a number of folks from the private sector. We've seen a number of commitments around deforestation-free supply chains. What's sort of the next step in engaging those and bridging the gap between what's feasible and what is actually used to meet these commitments?
I like to think with the experience we have with the financing sector. The Amazon Development Bank in Brazil, they have an internal policy that is more strict than the law in Brazil. Because according to the law in Brazil, you still can deforest 20% of the property. For this bank, they decide zero deforestation. So they're using this technology to support their policy implementation. But they are realizing that there is also marketing opportunity for them. Mm-hmm. They can understand better the landscape they're working, the type of potential clients that they can have using the information. This is also good for their business. So once they realize that they can use the information additionally to enforce their policies, they will start using more in combined balance the impact, sustainability impact, and also their business model.
Yeah, it's interesting to think kind of moving just beyond the commodities corporations to those who are financing them. And maybe that's a model that can be adopted elsewhere as well if it's working in Brazil.
For the supply chain, just quickly, we had been working with this area in Brazil to do traceability. It's a very complex problem. Mm-hmm. And the challenge we see is that different entities in the supply chain, they don't share information.
Yeah.
So we have also to make a change in behavior in this respect.
Yeah, I could comment on that, perhaps, that one of the things we're seeing, some of the largest consumer goods companies are coming to us about helping them with traceability in their supply chain because, there's sort of recognition that we need kind of radical transparency where the data is made much more available and open than it has been to date, and to the public, to advocacy organizations, and throughout the supply chain so that people can really know what's going on. And there are leaders in this. There are some companies that are more willing to be brave and to be more open about their supply chain, than others. And I think they're going to receive positive brand, reputation, recognition for this. So we see this. I've seen this over the last few years that there are leading scientists that will embrace new technology. There are leading, corporations that are going to make that bold first step. And benefits come to them, in many ways. And we need people to step up like that right now.
Yeah. Okay, so I think we have just a couple of minutes left. I want to hand it over to the sidebar in case there are any questions.
Thank you for that. I appreciate it. Great. You guys are speaking my world. I love this. So thank you so much. And you've actually hit a bunch of the questions that have come in already. There is a concern, though, with the access issue. So I think one of the big themes of this conference has been how to make sure that everyone can have access to these tools and to the data that they need to make these decisions. So the question is, how can you ensure equitable access, and also how can you ensure secure access, right? So people get wiggy about their data being collected, and even though it's a forest, someone cares, right? So that's the question.
On the platform side, I would say that we take that super, super seriously, and Earth Engine we view as a way explicitly to democratize access to satellite data for public benefit and to make it transformatively simpler for many, many more people all over the world to be able to do this type of, turning this data into knowledge and understand what's happening in their local context. And we do trainings all over the world. And I'm really, pleased to see that there are so many new kind of data analysts that are springing up again all over the world, able to use the cloud, whereas if they try to do it on a local computer, they have issues with storage and power failures, and people have said to us, our computers are 20 years old, and we can't do this locally. But we say, you just point your web browser, and all of the data is at your fingertips, the best science is at your fingertips, the computing is at your fingertips, and run with it. And we're actually seeing that happen.
From the application sides, it's all open source. That's what we're doing. We're also doing a lot of capacity building with end users. So it's following pretty much the same lines.
Mm-hmm. And I think from the data side, this idea of democratizing access, that's inherent in what Planet has done as well. I think, high resolution imaging from space kind of used to be the realm of governments. And as Andrew said, our founders came out of NASA with the idea of, we want to create a non-exclusive data set that can be accessed by anybody. And so that's very much in the DNA of what we're building as well. And as Rebecca said, I think also the capability, I remember studying remote sensing in college and waiting for a Landsat image to download. And so just the ability to use the data is going to get it into many more people's hands as well.
Can you imagine me? She's much younger than me.
All right, great. Well, join me again thanking Carlos and Rebecca for the discussion.
Thank you.